Good morning, students. In the last class, we discussed about some chemical properties of aldehydes and ketones. Today, we are going to continue with the same. So, before I remember that in the chemical properties, we already discussed the aldol condensation reaction. Okay, aldol and ketone. So, in aldol condensation and ketone condensation, what happens? The aldehydes and ketones, one which consists of alpha hydrogen. Okay, so they are going to react with each other. The alpha nitrogen atom of one atom reacts with the carbonyl group of other atom, and they react with each other. They form ketol form or aldol form. Later, by the elimination of water molecule, they form enols or ketones. Okay, so this is what aldol condensation. So today we are going to continue with crossed aldol condensation. Crossed aldol condensation. So in this crossed aldol condensation, so initially in aldol you are taking same type of aldehyde. Either both the reactants are aldehyde or ketones. But here in crossed aldol condensation, one reactant must be aldehyde, another must be ketone. Okay, so I'll take the general and remember in aldol condensation, crossed aldol condensation, the main thing is we have to choose the aldehydes and ketones that in such a manner they consist of alpha hydrogen. Okay, so example for that is at least one should contain alpha hydrogen. This is CH, benzaldehyde and acetophenone. Okay, so instead of that, listen here, you may take here CH3 also. You may take this also. Here alpha hydrogen is there, here also alpha hydrogen is there. No matter which is going to react with which one. Okay, so what happens? Here if I write this molecule as CH3, CH2, C double bond O, H. This is the reagent. So here it is CH2. I'll take this H here, C double bond O, and this is the benzene. The second product. Okay. So what happens here? So this H going to attach here, and these two bonded with each other. So here this one is common, CH3. This is also common, CH2. Here it becomes CH, and here it is OH. Why? Because this H combined with this O. So and these two are bonded with each other. That is CH2, and this is C double bond O. Okay. So then of course what happens? Condensation means removal of water molecule from here and here. Okay. Then this is CH3, CH2, CH, double bond CH, C double bond O. This is the reagent. Crossed aldol means remember same alpha carbon atom should present, and those going to react with each other, and upon elimination of water molecule they give enol or enone anything. Okay, but what you have to remember, so in a crossed aldol, one reagent should be a aldehyde, another should be a ketone, not same time. Initially in aldol I told you both should be. These two reagents must be aldehyde, these two reagents must be ketone, then it is aldol condensation. One is aldehyde, another one is ketone, then it is crossed aldol condensation. Okay, so here I have taken an example, one which consists of alpha hydrogen. Okay, so you may take example of benzaldehyde. Same. Okay. So listen. Benzaldehyde is here. Here if you take, so listen, this carbon is already bonded with the 4. Sorry, it's already tetravalent here. It has a 4 bonds. 1, 2, 3, 4. And there is no hydrogen here. This is the functional group means this is the alpha carbon atom. Okay? So in the alpha carbon atom there is no hydrogen. So the thing we have to remember here was at least anyone, either aldehyde or ketone should consist of alpha hydrogen. So now of course no matter here, only this is going to react with this. How can you write this? So this benzene, I will take here. So this benzene is written as C double bond O H, and this is written as CH2 H CH3, and this is C double bond O. This is the benzene ring. Okay, what is the first step? This H is here with this O, sorry, combined as here and from OH, and these two are bonded with each other. That is the reaction takes place. So when write as it is, this is the reagent. Okay, here CH is there. To this O, H is attached, and to this carbon, this CH2 is bonded. CH2, C double bond O, CH2. Okay, this is the first step. Later what happens? Here is an alcohol is also there, ketone is also there. Ketolytis. Then here, this OH and this H is removed. The final product you get is this is the product. So remember here, only the reaction taking place where at this position carbonyl group and this alpha hydrogen remaining R group is same. Okay, so this is what crossed order condensation. Order is also same, crossed order is also same. With respect to aldehyde, ketone, everything is same. So you have to remember one thing: they must and should consist of alpha hydrogen. This is crossed order condensation. Okay, so the next one chemical property is Cannizzaro reaction. Okay, next one is Cannizzaro reaction. So in this Cannizzaro reaction, we should contain especially aldehydes without alpha hydrogen. So initially what we consider alpha hydrogen. We choose a reagent that should contain alpha hydrogen. This Cannizzaro reaction is done or explained in the aldehydes which are not having alpha hydrogen. The only one aldehyde in an aliphatic compound which doesn't have alpha hydrogen is this formaldehyde. Okay, so you may take this also, of course. This is CH3, 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 CH1. So this is the alpha carbon atom. Here there is the hydrogen atom. So this can also be taken. But because of the presence of these three CH3 group, it occurs in a different manner. Okay. So this is the simple aldehyde which doesn't contain alpha hydrogen. Okay. So here what happens? This Aldehyde which is not containing alpha hydrogen reacts with KOH. Reacts with KOH. Okay, so they form HCOOK, means potassium salt of carboxylic acid. Okay, this is formaldehyde. This potassium formate. Okay, so students, later this is in 2 months, of course, this we have taken in 2 months, we form CH3OH. This one is alcohol, especially methanol. This is the reaction. Means when the aldehydes, of course we require 2 aldehydes containing no alpha hydrogen. They are not containing any alpha hydrogen. They react with potassium hydroxide. KOH forms potassium salts of carboxylic acid. We are taking formaldehyde as a reagent, means potassium formate and the methanol will form. Okay, that is, so this is for what? Aliphatic compound. Aliphatic means straight chain, not benzene ring. Okay, so if we consider benzene, of course this is also not containing. Okay, so listen, yes with KOH, here it is 2 moles. This one is what? Benzaldehyde, or you may take benzenol. When benzenol or benzaldehyde is treated with KOH, of course what it will form? In the place of H, benzene ring is there, R group. That is COOK. Okay, so this one is potassium benzoate. Okay, so next of course it forms CH2OH. Okay, so this one is benzyl alcohol. Remember, ZYL, benzyl alcohol. Okay, this is the reagent. Remember, here also same happen, like CH2OH, but here this one is a H, so it is CH3OH. Here also CH2OH. This one is the benzene. So remember, in case if you want to write a general reaction, we may write RCHO. Okay, upon reaction with KOH gives RCOOK plus RCH2OH. And remember, this is the note. R must be hydrogen or phenyl. Only hydrogen or phenyl. Then only, so this is the general reaction. They may ask like this also in the examination. So RCHO is there, KOH is there, they form these two. Then what must be the reagent? They may ask. Understood? So R must and should be hydrogen, R says 6H5, or they may give, as I told you, this type of compound like CH3, CH3, CH3. You have to remember what? You have to choose the carbon atom, one which is not having alpha hydrogen. Okay, this is Henry-Serres reaction. This is for aromatic. Again, this is an explanation. When aldehydes, especially formaldehyde or aldehyde which is not containing alpha hydrogen, reacts with this KOH, form potassium salts of carboxylic acid along with the alcohol. Not methanol. If formaldehyde is there, then only it is methanol. Here, general reaction. When aldehydes contain having no alpha hydrogen. Okay, those reacts with KOH form, sorry, here not it is H, this is C. Potassium salts of carboxylic acid and alcohol. That depends on this R2. It must be a phenyl or hydrogen. That's on your choice. If they ask aliphatic, so if they give different reagent here, like if they give methanol, then you should choose H here. R as H. Understood? If they give benzyl alcohol, then you have to choose benzene ring. Or instead of that, if they give this one, neopentyl alcohol, then you have to choose this one as a reagent. That depends on you, how to and how the concept is in your mind. Okay? So R group is different. We don't bother about the R group, it is a general reaction. So the reaction is only taking place in this carbonyl group. Okay? So this is all about a special type of chemical reactions exhibited by aldehydes and ketones. And students remember, these order condensation Cannizzaro reaction cannot be explained by ketones. Okay? So this ketones cannot exhibit or shows Cannizzaro reaction. What is the reason there? Means the ketone means on either side they consist of alpha carbon. Okay? So the ketone cannot be present like this. See. It is unstable, white. Okay? It is too complicated. And the scientist Cannizzaro only studied this reaction only on aldehydes, not on ketones. And remember, if we take ketone, both the side R group is there, and at least it consists of one or two hydrogen atoms. Then there must be a possibility of presence of alpha hydrogen. If alpha hydrogen is there, then it cannot be shown Cannizzaro reaction. Okay, that is the thing you have to remember. Next one is the nature of CO. So which type of reaction we are going to exhibit? These are special type, as I told you, named reactions and they are special type. And some other chemical reactions are there. So what is the reason for that? Listen. Carbonyl group structure is like this. So here it may be R group or hydrogen, whatever. One must be the R group, another must be hydrogen or anything else. Okay, this is the structure of carbonyl. Okay, you didn't consider this, you just need this carbonyl. So students, as I told you, due to the difference in electronegativity of carbon and oxygen, the electron of carbon is always towards oxygen, because oxygen is highly electronegative than this carbon. Then what happens if it is more highly electronegative? So it attracts the shared pair of electron towards itself. So then the electron of carbon is shift towards oxygen. So oxygen attracts the electron of carbon towards itself. So then what happens? So upon dissociation, the electron of carbon shift towards oxygen means it will get a minus charge, it will get a plus charge. So then which type of reaction is going to occur? We have to observe. This is the carbon. So this carbon exhibits the chemical property. So carbon is of which charge? Positive charge. And remember, here double bond is changes to what? Single bond. Always double bond changes to single bond means it must be an addition reaction. If single bond to single bond, then it is substitution. Double bond to double bond, substitution, because there is no number of atoms, bonds are not at all changing. If double bond to single bond, then it is elimination. Double to single means addition. Single to double means elimination. So remember, initially I told you here OH is there, so here CH2 is there. Elimination, then here double bond will form. Correct? So if any alkene is there, if HCl is added, it will form CH3, CH2, Cl, addition reaction. Double bond to single bond, addition. Single bond to double bond, elimination. If there is no change in bonds, then it is substitution. Okay, just replacing means substitution. Of course, here what happens? How the nature of the reaction will take place? So here it changes to double to single bond means it is a addition. Addition is doing where? In between these two. Especially we are going to study the chemical property of carbon. Okay, so carbon is of which charge? Plus charge. It attracts which type of species? Negative species are nothing but nucleophiles. So these exhibit nucleophilic addition reaction. Understood? Nucleophilic addition reaction means the carbonyl compounds always exhibit nucleophilic addition reaction. Remember in alloalkanes and alloarenes, I told SN1 and SN2 nucleophilic substitution. They are just atoms are interchanged. Nucleophiles are going to substitute. OH is removed, Cl is removed, OH is attached. OH is removed, Cl is attached. Then of course nucleophilic substitution. Here it is addition. Remember that. Okay. So then they show nucleophilic addition reaction means the negatively charged species attached here, positively charged species going to attach here. And remember, if any reagent, if it continues means it always accepts a proton and form C aldehyde. Okay, so listen, when this is in a carbonyl group double bond, then it is trigonal in shape and sp2 hybridized, and later it changes to, when the nucleophilic addition reaction takes place, it changes to sp3 hybridization and tetrahedral shape. This is the nature and the change in geometry of the carbonyl carbon after nucleophilic addition reaction. This is the nature and the characteristics of the compound. Okay, so by using different reagents, we are going to check which type of products they will form. Okay, so I'll take the general reactions. Initially, I write reagents here. Okay. So how this mechanism takes place? As I told you before, initially nucleophile will attach, then later hydrogen will attach. Two-step mechanism. First step is the greater enzyme. HCN. First reagent is HCN. In that, what is nucleophile and nucleophile means H plus and Cn minus. Remember this. I am not dissociating them. I am just writing one which is positive in charge, one which is negative in charge. In HCN, H plus is there, Cn is minus. Okay? So another one. NaHSO3. Okay? So in that, H plus is there, SO3 Na minus is there. This is the nucleophile. Okay? Next, take a ROH. R plus is there, OH minus is there. Correct? Next, fourth one, NH3. So in NH3, H plus, NH2 minus. Next, fifth one. Okay? NH2, NH2. This one is, remember, reagents I write, these reactions later I write. This one. Sixth one is NH2R. Seventh one is NH2OH. This one is hydroxyl amine. This one is amine. This one is hydrazine. This one is ammonia. Remember, these reactions are different. Later I will say. So this one, I will take the example of R, C double bond O, R. Okay. So students, in the reaction, what happens? This one will get the plus charge. This one will get the minus charge. So if you take HCN as the reagent, HCN as a reagent, what happens? H is in plus state, Cn is in minus state. So this is the nucleophile here. Nucleophile is going to attack to which atom? Either carbon or oxygen. Two atoms are there. So nucleophile is going to attack to which atom? Which is positive in charge among these two? Carbon. So of course the nucleophile which is negative in charge going to bond into what? This carbon. So then what happens? This is R, C, Cn, R. This one is OH. This is the reaction. Okay. So this is going to taking place in two steps. So in that, step 1, directly it is attack of nucleophile. Attack of nucleophile. Listen here R, C double bond O, R is there. So here nucleophile Cn minus is attack to what? This. Then what happens? They form R, C, Cn, R, O minus. So this is first step. So in step 2, addition of proton. Okay, so here it is R, C, O minus, here it is Cn, R plus H plus. This H plus is going to bond into this oxygen and then form R, COH, R, C. This is how the reaction takes place. This is the general reaction, of course. So you may consider this R group by substituting any aldehyde or alone. It must be aldehyde or a ketone. I am not telling you it is only aldehyde, it is only ketone. This R group must be hydrogen or aldehyde or aryl, any group. But this is the general reaction. And remember, don't bother about these two R group. Only the reaction is taking place at what? This carbonyl, carbon. Okay? So this is how the mechanism takes place. Mechanism of addition of HCN to the carbonyl compound. Important this one. Okay? They may ask only the mechanism, then this general reaction is enough for you people. If they ask the question, explain the mechanism of addition of HCN to the carbonyl group with an example, then you have to substitute these R groups by any of the substitutes. That are your own choice. They won't give any particular reagent in the mechanism. They'll just say you to write the mechanism with the example of your choice. Okay, so this is general reaction. And remember, once you know the reaction, you may easily write all these reactions. So listen, here if you take, instead of HCN, if you take NaHSO3. Okay, so in this, of course, which one is plus, which one is minus, you have to see. This is plus, this is minus. So minus is goes here. The proton is going here. This is the reagent we are going to get. So then in the mechanism, how can you write? This nucleophile means you are writing here this SO3 Na. So this is going to attack means it will form SO3 Na. This step remains as it is. Only the changes is what? Here. So in this reagent, you have to carefully define which one is the positive means electrophile, which one is nucleophile. Once you got that, then that is very easy to you people. Remember, here sodium is there, hydrogen is there. Ma'am, instead of sodium, why you are in sodium Na plus may also form, but you are choosing H plus Y. Why? Because this is the stable compound. When this oxygen is with hydrogen, it forms an alcoholic group that is stable. If this oxygen is with sodium, it will become sodium oxide, like alkoxide. Then it is unstable. To form a stable compound, here we require only proton, not anything. That is the one thing. Okay. And another one, if you want to say, the dissociation constant of hydrogen is more than this sodium. One which dissociate hardly, that is the electrophile which we are going to attach. Understood? Okay. So this is all about nucleophilic substitution. So in case of ROH also you will take. Here if you are taking ROH. Okay. Here there is no plus and minus charge is there. So okay. This is not sorry. This is H plus and RO minus. Because as I told you, oxygen requires hydrogen only. H plus and RO minus. Minus is here. Understood? Then here. ROH is attached. Which one is minus in charge here? OR. So this one is OH. So here if you want to take OR as a nucleophile, here you will get OR. So the remaining is same. Okay. So among these, this one is very important. Addition of HCl to tell us. They didn't ask addition of HCl to aldehyde ketone. The last addition of HCl to carbonyl group or carbonyl compound. This is the mechanism. Step 1, step 2. Step 2 is always same. Step 1 is different with respect to the reagent we are going to take. Okay. So this is all about chemical properties of the carbonyl group special. Next one is, if especially when they react with ammonia derivatives. So listen, when they react with ammonia derivatives, instead of addition reaction, they undergoes nucleophilic condensation. Nucleophilic condensation reaction. Of course, condensation means removal of water molecule takes place. Okay. So listen here, H plus is positive charge. So the negative species is going to bond it to the carbonyl group by the elimination of water molecule. In this NH3, it is NH2, H, NH2, H. So here carbon is there, carbonyl group. This H2O is removed, means this NH is bonded here. Of course, this is a nucleophile NH. Compared to hydrogen, nitrogen is highly electronegative. This will get the minus charge. Nucleophilic condensation. Condensation is taken by what? By the removal of water molecule. If any carbonyl group is going to react with these ammonia derivatives, instead of addition reaction, they undergoes condensation reaction. Here the bond order never changes, it is 2 only. So in these, you are going to check which one is going to remove. So listen, I take the general reaction. So C is there, R is there, R is there, double bond O is there. General reaction I got. Okay, so I take this ammonia initially. Here there is no mechanism. This ammonia I write NH3 as NH2H. Both are same. So here what happens? This H2 is going to remove. When it removes, it forms this R, C, R. Double bond is there. This NH is there. This is the okay. So plus H2. Okay. So instead of this, if you take this one, NH2, NH2. So I write here hydrogen directly, NH2, NH2. What happens? Condensation happens. This one. The product formula is what? R, C, R. Of course, double bond is as it is. H2O is removed means N, H. Understood? Next, R, C, R, double bond plus this one, amine, that is NH2, R. Okay, so this one is R, C, R, double bond, N. So students, this one is called as skiff reagent. Important for 1 mark. Skiff reagent. So listen, this is very important in the examination as well as in the laboratory. Laboratory Viva question is there for you people. In that Viva question, they'll ask what is skiff reagent, for what, to identify which group, which functional group we are going to use skiff reagent. Primary amine as well as carbonyl. If it reduces skiff reagent, it must be amine or aldehyde. Amine or aldehyde or ketone or carboxylic acid, anything. That is skiff reagent. Okay? And the next one is RCR double bond O plus NH2 OH. Here of course water is going to remove, we will get R double bond O, here it is NOH. Okay, so here the thing you have to remember, what if the carbonyl compounds undergoes or reacts with any ammonia derivatives. So listen here, here one H is replaced by NH2, another NH is replaced by R, one H is replaced by OH. These are the derivatives of ammonia. If the carbonyl groups, not only on the aldehydes or ketones especially, when they reacts with this ammonia derivatives, always they undergoes nucleophilic condensation reaction. By the removal of water molecule, they form this type of reagents. Okay, so listen here, this group is called as imine group. If it is the double bond NH group is there, that is imine. This is hydrazone. Right. This one is oxide. This one is oxide. Okay. So here I wrote already the name of the reagent. This one is ammonia, of course. This one is hydrazine, primary amine. So hydroxylamine. So when aldehydes or ketones reacts with hydroxylamine form oxides. When aldehydes or ketones reacts with primary amine, they form skiff reagent. When aldehydes and ketones react with hydrazine, they form hydrazone. When aldehydes and ketones reacts with ammonia, they form imine. Okay, remember. This is only the explanation. How to write. There is no reagents here. When they react with each other, they form this. This is the way to write the explanation. Okay, so you may listen here. I am not writing any example for this because as I told you, you may replace this article by any of your choice. It must be a hydrogen, alkyl, or alkyl. Alkyl means benzene ring. Okay. So next, if we consider, so this is all about the chemical properties. If we consider the physical properties of aldehydes and ketones, of course they don't have that much of boiling point compared to alcohols. Why? Because alcohols have the capacity to form hydrogen bond, but these, sorry, they are not soluble in what is that? Water. These are insoluble in water. Why? Because this CHO group is there. They are not consist of any hydrogen atom. If they form hydrogen bond with water, then only they are easily soluble in water. Okay. So because of the absence of the hydrogen atoms, they are insoluble in water. Okay. But they are soluble in organic compounds. And if we come to that boiling point, of course within them, this type of ion present. Here oxygen is there, here hydrogen is there. Intermolecular or intramolecular hydrogen bond is there. So because of that, they exhibit some boiling point and melting point. But those of boiling and melting point is less than the respective, greater than hydrocarbons, less than alcohols. Means, listen here. This is very important. Here I take CH3CHO and CH3CH3, CH3CH2OH. These are all of comparable masses. The parent chain is same, of the same group. Ethanol, ethane, ethanol. Okay. So here if you want to check the boiling point, so listen, this is alkane. The boiling point of this aldehydes or ketones, here I am taking aldehyde, is greater than this hydrocarbons. Compared to hydrocarbons, the boiling point of aldehydes and ketones are more, but compared to alcohols are same comparable masses, the boiling point and melting point is less. This is very important. This is what? Increasing order of boiling point. Means aldehydes and ketones have greater boiling point than the respective hydrocarbons and less boiling point compared to the respective alcohols. Means you have to consider, listen, CH3, CH2 is there, yes, ethanol, these two is there. We have to take, if the parent chain is with the 2 carbon atom, we have to take alcohol with the same 2 carbon atom. If here it is propanol is there, sorry, if it is ethanol, we are taking this one. Then the boiling point of this is more, because if the carbon chain increases, boiling point increases. Okay, long chain especially. If the branching increases like this, boiling point decreases. Remember, if the branching increases, boiling point decreases. If the long chain increases, boiling point increases. Understood? So this is all about physical. In physical properties, only two is the one is solubility, another one is boiling point. Okay? And remember, students, what is the uses of aldehydes means the special only one use is there, that is most abundantly used, formalin. 40% of formaldehyde is used as a formalin to preserve the species. You know, in biology, there are some specimens are placed in some type of yellow color liquid. That is nothing but formalin. Okay, so that formalin consists of 44% formaldehyde solution. Understood? This is the only one major use. This is all about aldehydes and ketones. In the tomorrow's class, we will discuss carboxylic acids. Thank you.